Greetings to all my tech heads out there in the KevTechify nation. And if you're new here, welcome. In this episode, we're going to look at network attacks. We'll be discussing denial of service attacks, distributed denial of service attacks, components of those attacks, buffer overflow attack, and then finally, we'll talk about some evasion techniques that threat actors use. This episode is part of my series on network security. I'm Kevin, here at KevTechify. Let's get this adventure started. A denial of service attack creates some sort of interruption of network services to users, devices, and applications. Now, there are two types of denial of service attacks. One is overwhelming quantity of traffic, and the second is maliciously formatted packets. Now, a distributed denial of service attack is like a denial of service attack, but it originates from multiple coordinated services. That's where the idea of the distributed comes in. If threat actors can compromise many hosts, a lot of hosts, and a lot of times you're looking at thousands or tens of thousands, they can perform a distributed denial of service attack. Now, this is typically referred to as a DDoS, so 2Ds OS. This DDoS attack are similar to denial of service attacks, except that when we do a distributed DOS attack, it increases the magnitude because it originates from multiple coordinated services. It originates from hundreds or thousands or tens of thousands of users, compromised devices, all at one time. Now, there are some terms you need to be familiar with when you talk about the different components here of a distributed denial of service attack. Zombies. This refers to a group of compromised hosts, and they're typically referred to as agents here. These hosts run malicious code referred to as robots, or if you shorten it down, it's bots. The zombie malware continually attempts to self-propagate like a worm. So it's trying to infect more and more computers, building up more and more compromised system, more robots, these bots. Bots are malware that are designed to infect a host and communicate with a handler system. Bots can also log keystrokes, gather passwords, capture and analyze packets, and they can do a lot more. Botnet here, this refers to a group of zombies, compromised computers here, that have been infected using a self-propagating malware and are controlled by handlers. These handlers refer to a master command and control, CNC or C2 server, so a command and control server controlling groups of zombies, a group of compromised hosts. The originator of this botnet can use IRC or a web server on the command and control server here to remotely control these zombies. And the bot master here, this is like Keymaster, this is the threat actor who is in control of the botnet and all the handlers. So you have compromised systems. These are the zombies that turn into bots with the software they're running. All of these bots together form a botnet. Handlers here refer to basically the servers that control the botnet, and then the bot master controls all of it. The Mirai botnet is one of the bigger, more well-known botnets that were discovered out there. And when you look at this, it's a fairly complicated system. Right here, these consist of our zombies. So this is our zombies in here. Zombies, once again here, are compromised system. They're compromised. Now, these zombies, what they're doing is they're running malware here. And this malware turns them into a bot. So this malware here turns them into a bot. These bots then, and once again, we can have tens, hundreds, or even thousands of these bots here. They're all sitting, they form our botnet. So we have zombies that are compromised system. They're running malware that turns them into a bot. And all of these bots here, that forms our botnet. Then we have our control and command center. These are some servers out here, or selected compromised systems that then control the botnet. They give them the instructions on what they're supposed to do. This is where the coordination of the attacks come from. So we have our command and control center at this point in time. We have our bot master. This is the bot master that controls everything. So our bot master controls the command and control servers that then command the botnet. The botnets report back to a report server somewhere. So this report server, it keeps a log of what they're happening. How many systems are compromised? When's the last time we've talked to these systems? And what was the results of our last attack? Now, this report server, the bot master can look at it and determine, is my system in good condition? Is it not? What can I do to improve it? Did I lose a lot of bots? Did maybe Norton antivirus or your antivirus software come out with something that uninstalled it all of a sudden my botnet no longer works? That's what the report server does. The report server also controls the malware loader. Maybe your antivirus software identified a small portion of it, but you can still communicate. So now the bot master has to connect into the report server with some new malware and load it up. And then the whole time, the botnet, these malware loaders, they're looking for new servers. So the malware loader, they can update software if it's still possible on existing botnets, or they can find new nodes here and load that malware in there and then bring them into the botnet. Once we have our botnet set up, we can then do an attack. And remember, we have 1,000 bots, we have 1,000 compromised system zombies in here running the malware that turns them into a bot that all attack this one individual at a time. Now, this individual, it could be a person or it could be a company like Amazon, or a couple years ago, Sony and its gaming was attacked. Once you have the system set up and working, a lot of the bot masters then they hire out their systems for pay right here. So they hire out their botnet that if somebody wants to do a denial of service against somebody, they can hire it out. And once again, payment is typically done in cryptocurrency. If you like this episode on network attacks and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. Click that notification bell to turn on notifications to be alerted every time I release a new video, and there's a lot more videos headed your way. You can also visit my website at KevTechify.com for all my details and how to get these episodes in video or podcast form. The goal of a threat actor when using a buffer overflow denial of service attack is to find a system memory related flaw on a server and exploit it. Exploiting the buffer memory by overwhelming it with unexpected values, unexpected values renders the system inoperable, creating a denial of service attack. What happens here is the threat actor runs a program or sends a command that uses up all the memory or corrupts the memory or overwrites part of it, and it causes problems on the system. And it appears like your system slows down, or maybe they figured out a way to get part of the memory and write it to the drive, and that particular memory is where your password's stored. Now, it's estimated here that 1/3 of the malicious attacks are results of buffer overflow attacks. Threat actors want to cause your system harm. And these threat actors, of course, don't want to get caught, but the people who are attacked, they typically want some sort of retribution. Now, there's several evasion methods that these threat actors use. First one here is an encryption and tunneling. This evasion technique here uses tunneling to hide or encryption to scramble malware files. This makes it difficult for many security detection techniques to detect and identify the malware. Tunneling can mean hidden, stolen data inside of legitimate packets. Resource exhaustion, this technique here, this evasion technique, makes the target host too busy to properly use security detection techniques. So it just overloads the processor. And because it's overloaded, they can't do real-time scanning. Target fragmentation. This technique, this evasion technique here, splits the malicious payload into smaller packets to bypass network security. After the fragmented packets bypass the security detection system, the malware is reassembled and may begin sending sensitive data. So let's take the big file, break it into smaller pieces, send it through your firewall, send it through your adaptive security appliance, and then it gets reassembled on the other end, and now the malware is active. It's compromising your systems. Protection level misinterpretation. What this evasion technique occurs when network defenses do not properly handle features like a packet data unit, like a checksum or a time to live value. This can trick a firewall into ignoring packets that it should check. Let's change some values here in the protocol level, and then maybe the firewall won't get it. Another evasion technique here is traffic substitution. In this evasion technique, the threat actor attempts to trick an intrusion prevention system by obfuscating the data in the payload. This is done by encoding it in a different format. For example, here the threat actor could use encoded traffic in Unicode instead of ASCII. Now, the IPS does not recognize the true meaning of the data, but the target end system can read this data. Traffic insertion is similar to traffic substitution, but the threat actor inserts extra bytes of data in a sequence of malicious data. The intrusion prevention system rules miss the malicious data, accepting the full sequence of data. Pivoting. Now, this evasion technique assumes that the threat actor has compromised an inside host and wants to expand their access further into the compromised network. An example here is the threat actor who has gained access to the administrator password on a compromised host and is attempting to log into another host using the same credentials. Rootkits are a complex actor tool used by experienced threat actors. It integrates the lowest levels of the operating system. When a program attempts to list files, processes, or network connections, the rootkit presents a sanitized version of the output, eliminating any incriminating input. The goal of this rootkit is also to completely hide the activities of the attacker on the local system. So rootkits hide that attacker was there, that threat actor was there. And finally, we have proxies. Network traffic can be redirected through intermediate systems in order to hide the ultimate destination for stolen data. In this way, known command and control servers cannot be blocked by an enterprise because the proxy destination appears benign. Additionally, if data is stolen, the destination for the stolen data can be distributed among many proxies, thus not drawing attention to the fact that a single unknown destination is serving as the destination for large amounts of network traffic. If we look back at that botnet model, zombies can be basically promoted up to command and control servers. And you can promote and unpromote these from command and control servers down to just normal bots on the botnet to continue to change IP addresses and destination for where that data is being sent. So it's a lot harder to track. It was my pleasure to provide you with this wonderful episode on network attacks. If you like this episode on network attacks and you got value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel and click that notification bell to turn on notifications. That way you'll be alerted every time I release a new video, and there's a bunch of videos headed your way. All my socials and contact information are on my website, KevTechify.com. You can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on network security. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on network security. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.